Alright, I'm glad you're watching this video to get help with Project 2. Lesson 6 has to deal with solving literal equations. What that means is when we have an expression or an equation, we can solve it for any variable we like by rearranging it using inverse operations. Alright, so for example, if we have the equation 2x minus 3y equals 5, I can solve this equation for y. If I have the interest formula equation here, A equals P times the quantity 1 plus R divided by T, if I really wanted to, I could solve for R. In fact, I can solve for any variable I want. Now the answer that we're going to get is going to involve another expression, right, with the other variables that are in that equation. You're not going to get an answer like 3 or 4 unless I tell you to let the variables equal some value. So let's do an example like question 1. Question 1. The value of 4 times x minus 15 is 7 more than 2 times x. Alright, so the first part of the question asks you to write the equation. So we got to write out this equation. So I'm going to go ahead and highlight the important parts of this equation. Alright. So the first thing I'm going to write here is 4 times x. Alright, so here's 4 times x. That means 4 times x. The word minus implies the operation of subtracting 15. So nothing too tricky there. So 4 times x minus 15. Whenever you see the word is, that does mean equal, because it is 7 more than 2 times x. So the way that I would typically write that is say if I had the quantity 2 times x right here, I would want 7 more than that. Okay, so add 7 to it. If you wrote 7 plus 2x, that would be the same thing as well. And so here I've written the value 4 times x minus 15 is 7 more than 2 times x. Now we're going to solve this equation. Notice that this equation does only have one variable in it, so we can solve it. We can get an answer for it. Alright, so in this case, if I solve this equation, my first step would be to go ahead and subtract 2x from each side. We're trying to gather our x's to one side and all our numbers to the other side because we have, in this case, variables on both sides of the equation. So my first step would be maybe to subtract 2x from both sides. All right, then I would be left with the equation 2x minus 15 equals 7. Alright, so I've brought my x's to the left. That means I need to push my numbers to the right. Because remember, we're trying to separate those two things on the sides of the equal sign. So my next step here would be to add 15 to both sides of the equation. Then I'd be left with the equation 2x is equal to 15 plus 7 is 22. And then the last step, to undo multiplying x by 2, we'd have to divide both sides by 2. So finally we get that x is equal to 22 divided by 2, which is 11. You can always check that you are correct by plugging your answer into the original equation, as long as the original equation you wrote was correct. So question number 2. What equation will have the same solution as the equation in the previous question? So we have to look back at question 1 and recall that we got the answer x equals 11. So what this is asking me is which one of these equations get 11 for an answer when I solve it. So that's what question 2 asks you in the project. So here's one that's quite like it. So more than one way to do it. One way would be to solve these equations just like we did the last one, using inverse operations, and then trying to see which one gave us the answer of 11. So you can try that. There might be a quicker way, I suggest. If we know that the answer is 11 to the previous problem, then why not go to the variable x in each of these examples here and replace it with 11? Substitute in 11 for each equation and see if you get a true statement. So to check if A is correct, I could replace the x with 11. and see if we get a true statement. So I'm asking, when I take 14 minus 11 and I divide that by 2, do I really get 3? Well, let's see. So I'm asking myself, do I really get 3 here? Okay, well 14 minus 11 is 3 over 2. Wait, 3 halves is not equal to 3. So it's not A. Alright, so we could do that with all the rest of these too. Let's see if B is correct. So if I plug in 11 for x, then I would have negative 11 divided by 2 minus 5 over 2. And we're asking ourselves, does that really equal negative 8? Does that really equal to negative 8? Alright, so since we have a common denominator already, I can go ahead and subtract these fractions. Right, so minus 11 minus 5 would be negative 16. And that's still over our denominator of 2. Does that equal negative 8? Yes, negative 16 divided by 2 is negative 8. Negative 8 does equal negative 8. So this one worked. So in this case, our answer was B. Now you could go ahead and verify that the rest of them didn't work, by substituting in 11 for the variable. So 11 minus 2 here would be 9. 9 divided by 3 is 3, not 1. In the option D, 11 divided by 2, that would give me 5 and a half. 5 and a half plus 6 is not equal to 3, so it's not C or it's not D. So that would be one way to go about the solution to a question like question 2. The other way would be to go about solving each of these individually for x, which in my opinion would take longer than what we just did. Alright, so let's do an example like question 3. Alright, so I made this one even a little more complicated than it was in the project. Okay, so we have this equation, h is equal to 12xy divided by 7z. Solve it for z. Alright, so there's more than one way to think about this. So remember, we're not going to get an answer like 5, right? We're going to get an answer z is equal to something involving all these other variables, including the h. Alright, so to isolate the z, I'm going to go ahead on the left-hand side here, and I'm going to rewrite this h as h over 1. Because remember, I can put anything over 1. I can write anything as a fraction over 1. It doesn't change the value of it. The now way is what I'm trying to do is get that z out from the denominator of that fraction. And one way I could think about it is like we do when we have proportions here, because think I have one fraction equals another fraction here. So as you may have learned in a previous course, to solve a proportion like that, you can cross multiply. So I could multiply these two together, h times 7z. So I would write that out, and I would have h times 7z, and I draw my z's with little lines through them so they don't get confused with 2's. And that would be equal to 1 times all of this, all times 12xy, which would just be 12xy. Alright, finally now I want to isolate the z. Notice that the z is being multiplied by both h and 7. Alright, so you can divide both sides by the 7h. Right? You could rewrite this h times 7 is the same thing as 7 times h, right? Because when we multiply, the order that we multiply in doesn't matter. Right? That's called the commutative property. So I can switch that order when I'm multiplying. And typically we write it in math so that the number is first, right? We call that the coefficient. So in this case, I'm thinking of it as a block. I might not know what h is, so when I multiply it by 7, I don't know what that is, but I know it's just some number. So if I want to take z multiplied by that number and I want to undo that, I'm just going to divide both sides by that number. So I'm going to go ahead and divide both sides by 7h. All of it at once, I can do that because it's all being times up here. Alright, so these things cancel out, and that's what gives us z by itself. Alright, so finally our answer is 12xy divided by 7h. Alright. So basically when we had this problem, just to kind of review real quick, all I had to do, right, if we have this eraser here, is cross multiply. I multiplied the 7z to both sides. So that way that I had the z out of the fraction. And then we had a 7h up here that was with the z on the left. Well, I just divided both sides by the 7h. And then z was all by itself, and we're done. All right, question 4. Given the formula that k is equal to the quantity n times z plus 1 all squared, solve the equation for z when n is 2 and k is 25. And then I also specifying that z is a positive number, and I'll show you why in a second. All right, so in this problem, I'm going to go ahead and replace the numbers that I know. I'm going to substitute them into our formula. All right, so k, it's saying, is 25. So where I see the k, I'm going to replace it with 25. It tells me that n is 2. And we don't know what z is. So I'm going to have to just leave that how it is. Squared. Okay, so now the question is solve for z. All right, so here's these parentheses. I'm trying to break that z out and get it all by itself, but this entire quantity is being squared. That has to be undone first. I have to get rid of raising all this to the power of 2. All right, and the opposite of squaring is taking the square root. So you need to take the square root of both sides. Okay? So when you take the square root of what's on the left here, on the right, taking the square and the square root, those cancel each other out. Those are the inverse operations. So square root and square undo each other. Then I just have 2x plus 1 here, and then on the right hand side. So I've broken that out from underneath that square. Now what we do to one side, right, we always have to do to the other. So I have to take the square root of 25 over here. All right, and the square root of 25 is technically plus or minus 5, right? When you force a square root, you have to get the plus or the minus of it. But that's why they said this in this problem, that z is a positive number. All right, so this should be a z, excuse me. Didn't mean to change the z into an x. All right, so that's why they specified that z was positive. All right, so technically this is plus or minus 5. And we're going to continue solving for z, and then we're going to make sure we have a positive value for z. All right, so using our inverse operations, I would subtract 1 from both sides. So then I'd have plus or minus 5 minus 1 is equal to 2 times z. Last step would be divide both sides by 2. So now z would be equal to plus or minus 5 minus 1 divided by 2. There's only going to be one answer because we're only going to want the positive answer. So notice if I let 5 be negative here, negative 5 minus 1 would be negative 6. And then negative 6 divided by 2 is negative 3. So we don't want that answer, right? It's specifying that z is positive. So I'm going to go ahead and let it be the positive 5. So now we know that z then should equal to 5 minus 1 divided by 2. In this case, z is equal to 4 divided by 2. And 4 divided by 2 is just 2. So in this case, z is equal to 2. All right, so the key to this problem was taking the square root of both sides first, right, to break out what's underneath in those parentheses out from that square. And then using inverse operations to isolate z. Remembering that z is a positive number, so you're going to ignore the negative square root and just focus on what we call the principal square root. And finally, the last question asks, how do you know that your previous answers were correct? All right, because in the actual project, they're relating the answers to culprits' names and locations. And so then they want to know how you know you were correct. And one way to do that would be to say that you could check your answers by plugging them back into the original equations. You could talk about the rules that you applied as far as using inverse operations to isolate specific variables. All right, so you could talk about what undoes one thing or another. And then where you can, right, like in the numerical answers, you can just talk about, checking your answer by substituting the answer you got into the original equation.